Hi, let's evaluate this integral y equal to integral 0 to infinity 1 minus cos x by x into e power x minus 1 into dx. Right? We'll use some technique, Feynman techniques. So let's say I of a equal to integral 0 to infinity 1 minus cos of x by x into e power x minus 1 dx. Our value will be I is, you can simply say I of 1, right? We'll calculate I of a, then if you substitute a value equal to 1, then you will get the value of I. So let's differentiate this value with respect to a. That means dou I by dou a. That will be integral 0 to infinity 1 will be 0, cos of ax will be minus cos of minus sine of ax, minus minus will get cancelled, then it will be sine of ax. Because we are differentiating with respect to a, x will be constant, right? X by x into e power x minus 1. This x will get cancelled, right? Which is integral 0 to infinity, sorry, dx, right? Sine of ex by e power x minus 1 dx. So I dash of a equal to, let's do one thing, integral 0 to infinity sine of ax multiply and divide with e power minus x. Then this will be 1 minus e power minus x. Right? This will be. So then I dash of a equal to, this can be written as summation n equal to 1 to infinity integral 0 to infinity sine of ax into e power minus nx dx. You can simply write, this rough work is e power minus x into 1 minus e power minus x whole power minus 1, right? 1 minus x whole power minus 1 is 1 plus x square and so on. So you can write it in the form of this summation. So this is what it is, right? Let's write clearly. As you can see, this function, right? This function is integral 0 to infinity sine of ax into e power minus nx dx. Okay, shall we derive this? Let's do one thing. Let's do integral 0 to infinity e power minus nx. This can be written as e power I of ax, right? Then this will be imaginary part of this. E power iax will be cos ax plus I sin ax, right? Into dx, which is imaginary part of integral 0 to infinity e power minus n e power minus n plus ia of x dx. Right? Then it will be im into e power minus of n plus ia x by minus n plus ia. Right? The integral limits are 0 to infinity. That is, imaginary part of e power minus infinity will be 0. Oh, sorry. Let's do one thing. Keep this part as separate. Right? then this part will be 0 minus of e power 0 will be 1, right? That is imaginary of minus 1 by minus of n minus I, right? This minus will get cancelled, then Im of rationalize this, then it will be n plus Ia by n square plus a square. The imaginary part of this is a by a square plus n square, right? Then I dash of a is summation n equal to 1 to infinity a by a square plus n square, right? Let's do some small modification here. Summation n equal to 1 to infinity divided by 1 by 2 and multiply with 2. That implies if you integrate with respect to a, then it will be I of a 1 by 2 summation n equal to 1 to infinity. This will be f dash of x by f of x, right? Then it will be n of ln of a square plus n square with respect to c. Then we need to find the value of c, right? So let's go here. As you can see here, I of a is 1 integral 0 to infinity 1 minus cos ax by x into e power x minus 1, right? If you substitute a value as 0, then this cos of 0, right, it will be 1. 1 minus 1 will be 0. Then I of 0 is 0, right? If a equal to 0, that implies I of 0 is 0. That is 0 equal to half summation n equal to 1 to infinity ln of n square plus c. That is c equal to minus half summation n equal to 1 to infinity ln n square. That is I of a equal to half summation n equal to 1 to infinity is common, right? If it is common, then it will be ln of a square plus n square ln of a square plus n square by n square, right? Ln a minus ln b equal to ln a by b, right? Yeah. Not to summation n equal to infinity ln of a square plus n square by n square, right? So let's do it. I of a equal to, how will you write this? Let's do, how will you summation ln of, it will be, if you substitute 1, sorry, 1 by 2 of, if n equal to 1, it will be ln of a square plus 1 square by 1 square plus ln of a square plus 2 square by 2 square and plus so on, which is half into ln a plus b equal to ln ab, right? Then it will be ln of a square plus n square by n square pi, right? In logarithm, summations and pi's are related. This is how you write it down. Now the interesting case happens. Let's see. I of a equal to half into pi, sorry, write it down. Write it down again clearly. Ln of pi equal to 1 to n equal to 1 to infinity a square plus n square by n square This can be written as half into ln of pi n equal to 1 to infinity. How can you write it down? 1 plus a square by n square. Right? I mean, this is if you are just dividing with n square. How does it look like? Right? How does it look like? I mean, I will show you some trick. Let's apply a trick here. Uh, this is sine function, right? How does it look like? It looks like this. And wherever it touches, there are 0, pi, 2 pi, and so on. Sin x is a function which is having roots at n pi, right? It will be x minus 0. It will have x minus pi. It will be similarly in this case into x plus pi, and so on. So sin x will be x into x square minus pi square, x square minus 4 pi square, and so on. If you take this x on left hand side, this will be x square minus pi square, x square minus 4 pi square, and so on. Right? Then this sin x by x equal to, let's do one thing. In the first term, let's take some pi minus pi square as common, then it will be 1 minus x square by pi square. Similarly, take minus 4 pi square as common here, then it will be 1 minus x square by 4 pi square. And all this terms of pi will be on the left hand side and let it be equal to beta. We'll evaluate how many betas, I mean pi's will be there in the beta. So and go, right? This is the case. And let's apply a limit here. Limit x tends to 0, sin x by x equal to, if limit goes to 0, then it will be 1, everything will get 0, right? We know that this formula is 1, then this will be beta. That is beta equal to 1. So sin x by x is 1 minus x square by pi square, 1 minus x square by 4 pi square, and so on. In a way, you can write sin x by x as pi n equal to 1 to infinity 1 minus x square by n pi whole square. Right? This is how we can write it. What is our equation? Our equation is half of, sorry, this let's evaluate only the pi terms. Pi n equal to 1 into infinity 1 plus a square by n square. Let's write it down here first so that it will be easier. Half ln of pi n equal to 1 to infinity 1 plus a square by a square, 1 plus a square by n square. Right? So from here, what if x is pi x? Then it will be sine of pi x by pi x is 1 minus, this will be pi x square by pi square, right? Then it will be x square. This part will be 1 minus x square pi square by 4 pi square, right? This will be 2 square. So sin x sine of pi x by pi x is pi n equal to 1 to infinity 1 minus x square by n square. right? In our case, this case, here it is written as pi n equal to 1 to infinity 1 plus a square by n square, which can be written as pi n equal to 1 to infinity 1 minus of ia whole square by n square, right? It's a clever trick. As I square is minus 1, this minus minus will be plus, then it will be 1 plus a square by n square. So here x is ia, right? Then pi n equal to 1 to infinity 1 plus a square by n square is sine of pi, x value is ia by pi ia. So this can be written as sine of I pi a by I pi a. Alright. Do you remember any formula from this? We know that sine of ix equal to I sine hx, right? That is pi n equal to 1 to infinity 1 plus a square by n square is sine, here x equal to pi a, then it will I sine h, x is I sine hx, right? I this pi a by I pi a, right? This I will get cancelled, then it will be sine h of pi a by pi a. That is I of a equal to, here it is, right, half into, sorry, ln of pi n equal to 1 to infinity 1 plus a square by n square is sine h of pi a by pi a, right? Our case is I is I of 1, right? That is a equal to 1. I equal to I of 1 equal to half into ln of sine h pi by a equal to 1 pi, which is ln of root of sine h pi by pi. So the final solution is integral 0 to infinity 1 minus cos x by x into e power x minus 1 dx is ln of root sine h pi by pi. This is the result.